Good morning one and all. Today in this live lecture we shall discuss the properties of operator E and delta CR. Actually in the last lecture we have seen that the definition of the shift operator, conditions of the shift operators. We have in the last lecture we have seen this detail here. That means in this first unit we have studied introduction, differentials, factorial notations, the operator E, the shift operator E. There are also two types, that is forward shift operator, backward shift operator. Properties of E and delta today we shall discuss. See this. Actually we have seen the factorial notation, the note on a factorial notation, x raised to 0 factorial is equals to 1, x raised to r factorial is equals to r into x into x minus h, x minus 2h dot dot dot, in this way x minus r minus 1 into h, in this way. These are the same conditions formulae which we have studied regarding the factorial notation. Also we have seen in the negative exponent form the given problem we have discussed here, that is h is the interval of differentiation, then we can write x raised to minus n factorial which is equals to 1 upon x plus h, 1 upon x plus 2h. Okay, we have seen in the detail previously. Okay. Now this is the factorial function. Factorial function x over n is given by the product function r is equal pi product function pi from r is equals to 1 to n x plus r minus 1. So this can be defined as x plus 1, x plus 2 in this way. Now the next important operator which we have studied in the last lecture, that is called as the shift operator. What is meant by the shift operator? An operator E is called the displacement operator, or it is called as a shift operator, and which is defined as E of f of x is equals to f of x plus h, f of x plus h, or we can write E is equals to f of x plus h. Means what here? Suppose this is a function, this is 0, this is a function y is equals to f of x, then at a point x we can write the value of that function f of x. There is a small increment in x, then we get x plus h, then its corresponding value of a function is f of x plus h. Now this shifts, f of x shifts towards the forward, then it gives the operator E. If we consider this as a f of x minus h, this is x minus h, then we consider the function f of x minus h, then if it transferred shifts in the backward, आता हा function इथं आला पाहिजे, so we shall draw this figure. I shall draw this figure in this way. Forward shift operator and backward shift operator means what? Suppose this is a x plus, this is a suppose x, suppose this is a x, this is a x plus h increment, this is a x minus h, this is x plus h, then the corresponding functions are f of x minus h, this is a x plus f of x, and this is a f of x plus h. If we shift f of x to forward, then it is called as a forward shift operator. See this, that is E. E of f of x is equals to f of x plus h. See this in this diagram. See this in this diagram. We consider f of x plus h. This is f of x plus h, f of x minus h, corresponding values. See this. then it shifts forward. It is a forward shift operator. If f of x shifts backward, then it is a backward shift operator e raised to minus 1. Okay, we have to define this. Now some note, some important formulae regarding the forward shift operator. E of f of a is equals to f of x plus h, where h is the interval of differencing. E square f of a is equals to e of f of a, means e of f of a, which gives the value f of a plus h. Again we operate this shift operator e, then it goes to f of a plus 2h, means e square f of a is equals to f of a plus 2h. In the same way, n of f of a means f of a plus nh, nth forward shift operator. This is e raised to minus, इसका मतलब backward shift operator, e minus f of a, e raised to minus f of a, which is equals to f of a minus h. Actually this is not index, this is not index, this is the shift, backward shift. So it is called as a backward shift operator. E raised to minus 2 f of a means f of a minus 2h. In the same way, in general we can write e raised to n f of a means f of a minus nh. इस तरह से हमने फॉरवर्ड शिफ्ट ऑपरेटर और बॅकवर्ड शिफ्ट ऑपरेटर के बारे में डिस्कस किया है. आता यानंतर पाहू वन मिनिट. Okay, now e square f square, e square of f square x is not equals to e of x bracket square. Put f of x is equals to x. So e square x square, which is equals to e of x square, means e of x square means x plus h bracket square. So we can write e of x plus h bracket square. This is the factorial equation 1. We have to show that e square f of x is not equals to e of f of x bracket square. So e square, put f of x as a x, त्यावरनं e square x square, which can be written as e of x square, means e of x plus h bracket square, e of x plus 2h bracket square. Also e of x bracket square, which is equals to x plus h bracket square, means x plus x square plus 2xh plus h square is equals to 0. So from 1 and 2 we can write e square x square, which is not equals to e of x bracket square. See this. Now next we shall consider the identity operator. What is mean by the identity operator we shall discuss here. The identity of here I or 1 is a unity, an operator is an operator which is such that the function on which it operates leaves the same function. Identity operator means if we operate that identity operator on any function, then it leaves that function as it is. एखाद्या फंक्शनवर जर आयडेंटिटी ऑपरेटर ऑपरेट केला तर ते फंक्शन ॲज इट इज राहतो, त्यामध्ये बदल होत नाही, हे आपल्याला इथं सांगायचं आहे. सो आय ऑफ एफ ऑफ ए इज इक्वल्स टू एफ ऑफ ए, एफ ऑफ ए इज एफ ऑफ एक्स which can be written as I into f of a or I of f of a. F of x is equals to 1 into f of x. In this way we can write 1 or I is called identity operator. त्याचे काही टर्म्स आहेत, या आपण काल डिटेलमध्ये पाहिलेले आहेत. आता परत इथं डिटेलमध्ये पाहायची गरज नाही. वी शॅल डिस्कस द प्रॉपर्टीज ऑन ऑपरेटर. नाउ फर्स्ट प्रूव दॅट E is equals to 1 plus delta, or we can also write prove that E is equals to I plus delta. This is a very important relation which we have to prove. E is equals to I plus delta. You know that. चला रे स्टुडंट्स, आता सर्वांनी मला डेल्टा म्हणजे काय सांगायचे आहे, आय म्हणजे काय सांगायचे. तर अगोदर डेल्टा डिफाइन करा. डेल्टा एफ ऑफ एक्स, हाऊ टू राइट द डेल्टा एफ ऑफ एक्स. संध्या, गोरे, आकाश, नाउ यू टेल मी व्हाट इज मीन बाय डेल्टा एफ ऑफ एक्स. लेट y is equals to f of x be a function and h be the interval of differentiating. Then we have the relation. अभी देखो हमें relation पता है. We have, what is the relation? We have delta. We know that delta f of a, how to write delta f of x, which can be written as delta f of a. We can write delta f of a किंवा delta f of x असं सुद्धा घेऊ, काही अडचण नाही. delta f of x is equals to f of x plus h minus f of x. Also we know that e of f of x is equals to, what is the formula for e of f of x? We can write f of x plus h. Now delta f of x is equals to f of x plus h minus f of x. So we can write f of x plus h can be written as, suppose this is 1, this is a second. Delta f of x plus h can be written as e of f of x minus f of x, which can be written as a delta f of x. See this, if we take the common f of x, then we get delta f of x, which is equals to e minus, we can write I or 1 of f of x. So by the comparing we get, therefore delta f of x, here delta is operator on f of x, e minus 1 or e minus I is also operator on f of x. So by comparing we get the operator comparing, we have delta is equals to e minus 1, or minus 1 can be shifted towards the left side, so we can write e is equals to, or delta plus 1 is equals to e, or we can write therefore e is equals to 1 plus delta. Or we can, this one can be written as an identity operator or I, so we can write e is equals to I plus delta. This is the same process and hence proved. See this is a very simple proof. सर्व विद्यार्थ्यांना सूचना आहे, पहा प्रेझेंट टाकून जात आहेत, लक्षात येतं. चला नाव सांगा रे, मला चॅट बॉक्स मध्ये प्रत्येकाने आंसर लिखना गरजेचं आहे. नाउ यू टेल मी व्हाट इज मीन बाय शिफ्ट ऑपरेटर. अभी आपको शिफ्ट ऑपरेटर बताना है, व्हाट इज मीन बाय द शिफ्ट ऑपरेटर. So this is the prove that e is equals to 1 plus delta, or we can also write e is equals to I plus delta. Let the function y is equals to f of x and h be the interval of differentiating. Then we know that according to the definition of a forward difference, delta f of x is equals to f of x plus h minus f of x. Also we know that the definition of the shift operator, E of f of x is equals to f of x plus h. Now put this value second in 1, put the value of second in 1. So delta f of x is equals to f of x plus h minus f of x. So delta f of x is equals to E of f of x minus f of x. Take out a common f of x. Then we get the result is that comparing the operators, then we get the result. Okay. Now we shall discuss the second. Prove that e raised to x, which is equivalent to 1 plus delta raised to x. 1 plus delta raised to x. Now we have to prove this result, second result which we have to prove. See this. Let f of x be a function and h be the interval of differencing. So we can write this size. So by we know that delta f of x is equals to f of x plus h minus f of x, and E of f of x is equals to f of x plus h. See this. This is the displacement operator, you know that. Now we have to prove that e raised to x, which is equals to 1 plus delta raised to x. So here x is a positive integer. Now we can write E of f of a, which is equals to f of a plus h, and E square of f of a, which is equals to E of f of a E of a. So E of f of a plus h, that can be written as f of a plus 2h. So now we know that f of a plus 2h can be written as f of a. This can be written as f of a plus 2 times of delta f of a plus delta square f of a. तुम्ही याला सॉल्व करा म्हणजे f of a plus 2h मिळतं. तुम्ही पहा हे सॉल्व करून. So this can be written as which is equals to 1 plus 2 delta plus delta square of f of a. So we get the result E square f of a, which is equals to this. That means E square of f of a, which is equals to 1 plus delta bracket square f of a. This implies that E square is equals to what? 1 plus delta bracket square. But you know that we have proved. We know that we have already proved that E is equals to 1 plus delta and ether. Here we can write this size also. We have E is equals to 1 plus delta. Suppose this is equation number 1. Now E is equals to 1 plus delta. We have proved E square is equals to 1 plus delta square. So in general, if x is a positive integer, then we can write e raised to x is equals to 1 plus delta raised to x, or we can write e raised to n is equals to 1 plus delta raised to n, and hence proved. हे मात्र तुम्हाला व्यवस्थित करावं लागेल. f of a plus 2h हा जो पार्ट आहे, f of a plus 2h can be written as f of a plus 2 delta f of a plus delta square f of a. याची व्हॅल्यू f of a plus 2h तुम्ही सॉल्व करा म्हणजे तुमच्या लक्षात येतं. ओके, नेक्स्ट वी हॅव टू प्रूव्ह द थर्ड प्रॉपर्टी. Prove that delta f of x plus g of x plus suppose h of x plus dot dot dot, then that can be written as delta f of x plus delta g of x plus dot dot dot. It is also called as a distributive law. We can say that distributive law property. This is the distributive property. We have to prove this distributive property. Means delta of addition of the different functions, that is f of x plus g of x plus k of x plus h of x, whatever may be, then we can separate the delta. That means we have to prove this distributive property. Chalo, we can write this. Here we shall take the LHS or left hand side, that is delta f of x is equals to delta f of x plus g of x plus dot dot dot. How to define this? We know that f of delta f of x is equals to f of x plus h minus f of x. So this can be written as f of x plus h plus g of x plus h plus dot 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 minus, we can write minus f of x plus g of x plus dot dot dot. See this, f of x plus h means f of x plus h minus f of x. So consider this function as f of x plus h minus this is f of x. Now separate this, we can separate this. F of x plus h minus f of x. Collect these two terms, this term and this term, plus g of x plus h, minus into minus, plus into minus means minus g of x, plus dot dot dot. So this can be written as f of x plus h minus f of x can be written as a delta f of x. G of x plus h minus g of x means that can be written as a g of x plus h plus dot dot dot. Hence delta f of x plus g of x plus dot dot dot, which can be written as delta f of x plus या इथं राहिलं पहा delta g of x, delta g of x plus dot dot, and hence proved. ओके, अशा पद्धतीने आपण ही डिस्ट्रीब्युटिव्ह लॉ प्रूव्ह करू शकतो. Then we have to prove the commutative law. Next, second, commutative law. Similarly, हा डिस्ट्रीब्युटिव्ह लॉ झाला डेल्टा साठी. सेकंड, हे डिस्ट्रीब्युटिव्ह लॉ प्रूव्ह दॅट डिस्ट्रीब्युटिव्ह लॉ त्यातला हा फर्स्ट झाला. ये सेकंड घेऊ आपण. E of f of x plus g of x plus dot dot dot, which can be written as E of f of x plus E of g of x plus dot dot, means distributive law for the E of f of x. Now E of f of x plus g of x plus dot dot dot, this is a formula for f of x plus h plus g of x plus h plus dot dot dot. But f of x plus h can be written as E of f of x. G of x plus h can be written as plus g of x plus h, g of x plus dot dot dot. In this way we can write E of f of x plus g of x plus dot dot dot, which is equals to E of f of x plus E of g of x. Plus dot dot, and hence proved. ओके, अशा पद्धतीनं हा E of g of x होतो. बरोबर आहे प्रणित मुळे, व्हेरी गुड. Means we have proved the distributive law for delta and E. Similarly, we have to prove the commutative law. We have to prove the commutative law with respect to the constant. Prove that symbols delta and E satisfies commutative law, satisfies the commutative law with respect to constant only. Now see this, let y is equals to f of x be a function and h be the interval of differentiation. Let C be the constant, we have, what is the formula? Delta f of x. What is the formula? Delta f of x is equals to f of x plus h minus f of x. E of f of x is equals to f of x plus h. Number 1. Now, delta of c into f of x, we have to prove the commutative law. Delta of c into f of x is equals to how we can write? That is equals to c into f of x plus h minus f of x. C into f of x. We can take a common c, then we get f of x plus h minus f of x. So that can be written as c into delta f of x. So we can write this as, therefore, delta of c into f of x, which can be written as c into delta f of x. Same process for E. Second, E of c into f of x, that can be written as c into f of x plus h. C as it is, f of x plus h can be written as E of f of x. So we get E into Cf of x, which is equals to c into E of f of x. See this, and hence proved. Okay, next we have to prove the next concept. Next, third, fourth, prove that, what is that? See this, third, tisra. Prove that delta raised to p, again delta raised to q of f of x, which is equals to delta raised to p plus q f of x. See this, we have to prove this delta raised to p of delta raised to q f of x, which can be written as delta raised to p plus q f of x. See this proof. Now left side, delta raised to p of delta raised to q f of x can be written as delta raised to p delta raised to q f of x, that is equals to, delta raised to p means what? Delta 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 dot 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 p times, again delta delta dot 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 q times of f of x. Delta raised to p means delta of delta of delta of p times delta of delta of delta q times. This means that delta of delta of delta of dot 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 p plus q times. You know that delta of delta f of x है, so we can write delta square f of x in this way. So we can write this as a delta raised to p plus q f of x. Therefore, delta raised to p, delta raised to q f of x can be written as a delta raised to p plus q f of x, and hence proved. म्हणजे अशा पद्धतीनं हा आपला इथं properties, these are the different properties which we have to prove. See, this is the first property we have to prove that E is equals to 1 plus delta. This is a simple proof. Second, prove that E raised to x which is equals to 1 plus delta raised to x. So this can be written as, suppose this is the second. Then we can write this, then distributive law, then commutative law over the constant c, and we have proved delta raised to p, delta raised to q which is equals to of f of x is equals to delta raised to p plus q of f of x. See this. अशा पद्धतीनं आपण हा टोटल प्रॉपर्टीज प्रूव्ह केलेल्या आहेत. आता या प्रॉपर्टीज परत उद्याला लिहू, यात काय आणखी प्रॉपर्टी राहिलेल्या आहेत त्या बघू. See this. Next, we have to prove the next property, that is what is that property? See this. Next, 1 minute, again we shall prove the property, next property. Prove that third, fourth, prove that if m is a positive integer, then we can define the symbol delta raised to m as, how can write, according to the property first, by using the property. See this, by property this 3 प्रॉपर्टी किती आहेत पहा बरे, परत एकदा पहा बरं, प्रॉपर्टी जास्त झाल्यावर वाटतंय मला. सी दिस इज द प्रॉपर्टी 1, this is a property 2, this is a property 3, 4, see this, this is a 3, that is a 4, ही 5, ही 4 property आहे. This is a suppose property number 5, and this is the property number 6. By the property number 5, we have delta raised to m of delta raised to minus m f of x, that can be written as delta raised to m minus m f of x, that is equals to f of x. So we can write this as delta raised to m, delta raised to minus m f of x. Okay, this property we have proved. And the last 7th property, prove that E delta which is equals to delta E, E of delta which is equals to delta E. Now we have E of delta f of x, that can be written as E of delta f of x, that is equals to E of delta f of x. How to write the student delta f of x? F of x plus h minus f of x. So we can write E of f of x plus h minus E of x. So we can write E of x plus h means E of x plus 2h minus E of x plus h. E नहीं, f of x plus h, f of x plus h. So it gives the value delta f of x plus h, and f of x plus h means, which is also given that delta of E of f of x. F of x plus h means delta E of f of x. Therefore, we can write E of delta f of x, which is equals to delta E of f of x. This implies that E delta, which is equals to delta E, and hence proved. See this, अशा पद्धतीनं या 7 प्रॉपर्टीज चांगल्या पद्धतीनं लिहून घ्या. We can prove the 7 properties. In this way we can prove the 7 different important properties. Okay. आता काही विद्यार्थ्याची आज कॉम्प्युटरची परीक्षा असल्यामुळं त्यांनी व्हिडिओ नंतर पहा, व्हिडिओ नंतर पाहून मग लेक्चर्स पाठवून द्या. नाउ वी शॅल स्टॉप हिअर. नमस्कार, गुड बाय. काय अडचण आहे का विचारा रे. ज्योती पिटले, कृष्णा आले, श्वेता शिंदे, प्रियंका धनुरे, काय अडचण आहे का पहा. या प्रॉपर्टीजमध्ये 7 प्रॉपर्टी आपण प्रूव्ह केलेल्या आहेत पहा. या 7ही प्रॉपर्टीत काही जर अडचण असेल तर विचारा. ओके. नाउ वी शॅल स्टॉप हिअर. गुड बाय.